So an equilateral triangle, all the sides are the same. They want us to call the side lengths S. We're supposed to find the area of a triangle. The area of a triangle is 1/2 times the base times the height. And a base and a height of a triangle are just two things that make right angles. Okay? So if I drew a line down here, and if we could just find out what that dotted line is, that could be the height, and this S is going to be our base. Okay? So to figure out what that height is, it's going to bisect that angle perfectly into two even angles on either side of it. So that means this side over here is 1/2 S. And so a squared plus whatever this b squared is should equal c squared, because that makes a right triangle, right? So we got to use the Pythagorean theorem. That a squared that I mentioned, s, plus, I don't know what this is going to be, so we'll call that h for height, equals our c squared, the hypotenuse. And now we've got something to solve for the hypotenuse. We can square this. It's 1/4 s squared plus h squared equals my terrible looking s. It looks like a 5. Come on, I'm 33 years old. Should be able to do that. Subtract 1/4 s squared from both sides. So you get h squared equals 3/4 s squared. Because 1 whole s squared subtracted by a 1/4 s squared makes 3/4 s squared. And then we got to take a square root, and we'll ignore the negative answer. Because remember, we take a square root, you got to think of the positive and negative. And the square root of a square just makes s. So this is our formula for h, for the height. So we're almost done. We almost have the area for part A. It's 1/2 a base, which is the entire length across, times the height. So it's 1/2 base times the height, which is square root of 3/4 s. That's it. Okay, and then you could clean that up a little bit. Because square root of 3/4 is the same thing as square root of 3 over square root of 4. And square root of 4 is 2, right? So you got 1 times square root of 3 makes square root of 3 in the numerator. And then you get 2 times 2 makes 4 in the denominator. And s times s makes s squared. So there's a cleaned up version. So with function notation, you just put a parentheses right here. A of s is equal to square root of 3/4 s squared. Find the instantaneous rate of change of the area with respect to side length s. That just means we need to take a derivative of a with respect to s. So the power rule happens. The 2 comes down and multiplies. So that's square root of 3 over 4 times 2. That makes square root of 3 over 2. And that's s, because the 2 came down and multiplied. Evaluate the rate of change of a at s equals 2 and s equals 10. So that just means we're supposed to plug in 2 into the derivative. So square root of 3 over 2 times 2 just makes square root of 3, and I'll leave plugging in 10 into u. That's just plugging it into the derivative, right? Because the derivative is a machine that can always spit out instantaneous rates of change for you. And then part D, if S is measured in inches and A is measured in square inches, what are the units? Remember, this is shorthand notation for the derivative of the area with respect to the side length. So the units of area, it's two-dimensional, that's inches squared. And the units of your side length is inches. So those are the units of the derivative.